Briefly introduce Brad and Buster. So before we put formal slides, so I've been working with Brad for almost 10 years. He was so when we started the future program of 5G initiative, whatever, right? So I worked with him. He was the program director, and then Greg came along later. But we have been some of these programs like CPU, Future Network. I started working with Brad. He's a staff program director and a volunteer. But then when Craig took over the Future Network, we wanted to do something different and new that could be useful for humanity. So Anwar Al-Dalai was my other co-chair, and Brad and I and Josh, few others. We really worked for 2 years before we got some funding from New Initiative Committee. And I'm really passionate and proud about what we have done. And you can see something there. Along the way, we had entrepreneurs like Bhaskar who came along and he wanted to join the force. He had some new ideas about use cases. So I leave it up to Brad and Bhaskar to talk about it. There is a booth there. The many universities already started subscribing to the 5G innovation. With that, Brad, I'll make you, I didn't read your formal bio, but okay. So I work with Bhaskar in 18 labs and with Brad, obviously. I've been many years. Thanks, Brad.
Thank you, Ashutosh. Thank you. I'll try and make my part quick so that Bhaskar can show the more technical parts. But I'm going to provide an overview of the 5G 6G Innovation Testbed, which is a new offering by IEEE, help spearhead, and it is not something that I think directly can say it addresses the digital divide, but there are ways that those who are worried about the digital divide can use the testbed, or the testbed can assist with those who are passionate about closing the digital divide. And the idea for all of this started in 2020, and not to remind you of the bad days, but that's when we were all on lockdown from COVID, and all of the 5G test labs in universities around the world were shut down. No one could go to them. Work had stopped. And then we started seeing reports like this from McKinsey saying that while 55% of executives said innovation was their number one or number two priority before the pandemic, that percentage plummeted to 23% after the pandemic. So we were also seeing companies taking money away from their innovation teams. IEEE volunteers like Ashutosh and Anwar were becoming concerned that the innovation work was going to slow down with the lab stopped and companies taking money away. So we asked, what can IEEE do? And we thought about the biggest challenges that engineers face when it comes to 5G testing and development. And first and foremost with cost. It's very expensive to build and maintain a 5G testing and development lab. There are also problems like customization for the specific kinds of testing you want to do, availability of test beds if you don't build your own, collaboration with other partners, companies, other universities, end-to-end coverage was sometimes an issue, and then bias. We felt that IEEE is a global neutral organization known for technical excellence could spin up something that is not just low cost, but would be viewed as being operated without bias. And so that's when we sought funding from IEEE to build this 5G 6G innovation testbed. And what it is a cloud-native end-to-end 5G network testing and development platform. So we went back to that time in the pandemic and thought, let's not start like other 5G labs by buying a bunch of equipment and having them shipped to a physical location. Can we build something that is exclusively in the cloud? That is also end-to-end exclusively in the cloud. And we did that mostly through open source components. But it is also a hybrid system. So if you have hardware at your premises that you want to connect your IEEE testbed account, you can do that. You can also upload your software into the system and have it interact with the end-to-end network environment. So it is a place where you can do lots of testing, interoperability testing, conformance testing, to the standards, load testing, security testing, but it's also a place for sandbox innovation. So it's something that might become a proof of concept and then maybe it's ready for testing. But for now, it's just an idea that you want to try out. This is an environment where you can try that idea out. That might be new network optimization, new products or services that would use the 5G network. And so the idea here is that this would reduce development costs. And so, the connection to connecting the unconnected is that the way we've lowered the cost to access for this kind of platform is really going to democratize, access to 5G testing and development. We're seeing universities that don't have the budgets to have labs take advantage of this to great effect. And in industry, it shortens the feedback loop. The high accessibility of the platform means you can do a lot of testing really quickly, get the early stage failures and bugs out of the way, and just speed the time that it takes to get to something that works. From a technical side, we have multiple architectures available. Most of what we have is in the cloud. The core, we have a toolkit with lots of tools, APIs, and more. For the end-to-end fully virtual network, of course, the RAN and UEs is all emulated, and that's what's available 24/7 from your laptop. But it includes Open RAN and a RIC, again, fully virtual end-to-end. But then the ability to connect your hardware and physical layer testing is important. We have an edge environment if IoT or MEC testing is important. And it's available in the cloud, but we can also support giving you something to install on your premises if that's important. We add a lot of tools into this system. Most of them are open source, some of them are not. We support both of the major Open RAN, open source software initiatives, and we've included the Camara API project and support use or development of more APIs. But some of these are companies that are proprietary companies, and they're putting their tools in the test bed because they want to get exposure. They want people who are, maybe students and going to be entering the workforce, or young professionals to be familiar with their tools, so that when they go into the workforce, it's a tool that they know. And of course, every company wants that. Although it's a lot of open source components, which of course are all over the internet, we built a user interface that stitches them together and makes them a whole lot easier to use as an integrated end-to-end network. And so the user interface will enable direct access to specific use cases like the APIs or setting up network slicing experiments, and then direct access to some of the most popular tools like traffic control, trace analyzer, and a speed test tool. So for industry, we think that this will help product development. We think it will help them with network and services development. It's a great way for them to collaborate with partner companies in a virtual space where people don't get to have to get together physically. And it's an opportunity to upskill the workforce, whether that's young people who need more training or veteran employees who might be great with 5G but need to brush up on, might be great with 4G but need to brush up on 5G. And again, we think that shortening the feedback loop and accelerating time to market is a big benefit. In academia, we're seeing a lot of research projects happen, PhD research projects, capstone projects, and especially at universities that don't have a 5G lab. And so for them, where faculty or students may have had a great idea that turned into a paper, now they can take that idea, do some testing or experiments in the test bed, and now they have data to go along with their idea. And so when they submit that paper, it actually has data to go against it that was generated in the test bed. And in that way, the test bed ties together nicely with the other IEEE products like Dataport and Explorer. But it's also just a great hands-on learning. So you can teach the theory in the classroom about 5G, but then being able to give that student the opportunity to go in a system that gives real-time feedback and is like a semi-live network to get hands-on experience. And so you learn the theory of network slicing or of using APIs. Then you can go and actually try a network slicing test or use an API in a semi-live network. And we hope that that makes them more confident and more ready to enter the workforce. This is a list of the capabilities and functions we've implemented. I'm not going to read through them. The slides will be available. I will show one though, and so this is a dynamic quality of service experiment in the fully virtual network. So we'll stream a video through the network, and then we're going to create congestion in the network that will degrade the quality of the video. But then we're going to show how we can use an API enabled by the Chimera project to modify the DSCP values and improve the performance for that user. So this is the video streaming without congestion. And if we look at the Wireshark, there's no special DSCP marking done on the packets. Then we use the iPerf3 as a tool to inject simulated congestion, and the video quality suffers. It gets pixelated and blurry, and it slows down. Now, if we use an API enabled by Chimera to set a desired DSCP value for streaming users, and then configure those rules in the testbed user interface, then when we stream the video, the quality improves. And when we look at the Wireshark, we see exactly where the values were modified to improve the performance for that user. And this is a side by side. The top right is the one with congestion and with the API helping that user. And it's pretty hard to tell between the two on the top, whereas the one on the bottom is the one that lags behind and is very blurry. So it's a simple demonstration, but one to show how you can use things like APIs to teach the network to treat some users differently than others. And in use cases like, in a community where bandwidth is limited and there's a lot of resource sharing and connecting the connected type scenario, that's where APIs like this can really come into play to deliver the best user experience possible. We have some testimonials from these universities that don't have their own lab. I'll let you read them from the slides. One team even wrote a paper about using the testbed that will be published as part of a conference proceedings. And we do have a development team. So we don't consider this platform finished. We're always working on new use cases, putting new tools in. And whenever we get customers, we ask them, what are you working on? What do we not have that you need? And we're, customer feedback very serious. So I'm going to turn it over to Bhaskar now, and he's going to talk about some more specific use cases that could be applicable in connecting the unconnected scenarios.
Thank you, Greg.
I have a table outside, and if anyone wants to see our user interface or ask me questions, I'll be here later on. Thank you.
Yeah, thank you, Greg. So we had to have discussions with Brad and Dr. Astosh, and we brought this IEEE 5G60 testbed into the Invensys lab. So Invensys is we are already working with all the tier 1 operators and OEMs in US and North America. And we are specialized in 4G, 5G, 6G, and VoLAN private networks. And we have seen this kind of solutions in the past, like Magma or 5GS, multiple which are used productively or some of the pro contests. But the IEEE 5G60 testbed, it's more than that. It's actually like when we started using it, which is in the AWS platform, and we started developing some of the use cases that we want to do. So what we have seen, like the 4G broadband, as some of the speakers mentioned. So yeah, 4G gives whatever the uplink and downlink which is needed to the carrier aggregations and other facility where definitely there is a change from the 3G to 4G, a big packet core network. And the 5G is coming in and bringing the cloud native era, which is complete physical network functions and virtualized, containerized, and even on-prem on the cloud and building. So we build the private networks on top of it, right? And today's concept, connecting the unconnected. So we have been working multiple rural communities, especially the tribal communities, as well as in Alaska, we have deployed recently one system we're working on in Nebraska, one is in North Dakota. So we have been working a lot of rural communities to see how we can take this technology, right? And it's more about use cases, how we drive the use cases into. So, and the 6G, it's too early to talk about, but mostly it is autonomous, and it will be kind of having a lot of closed loop functions inbuilt and automation deployed, and most of the physical network functions and virtual network functions will be the same function, but it will have some multiple applications that come. So this is the lab where we have taken the 5G innovation test bed connected, and we started working with some of the real OEMs. So this lab is managed by inventors, and we have around 30 servers making noise, where we have 6 different RAM vendors and 6 different core vendors. And we brought this 5G test bed, and we looked into that, and we started looking into the use cases, not only for data, which is uplink, downlink, and throughput. Also, we want to do some of the voice over LTE and slicing, right, and some of the 911 calls. And these are some of these use cases we started developing and our team. So this is one of the interesting use cases that are developed, where this is used for the mission critical disaster recovery, especially for the rural area, and on demand to provide the 5G, 6G kind of services in future, right? And this is the cell on the wheels that can be go on the on the truck, and it can be connected back onto the satellite. You can see one of the demo that is outside of this, and with the 5G test bed. We also brought a demo, which is more like discussing about some of these use case using a Starlink backhaul in order to connect them, to the internet. And also this particular example where we have kind of deployed this in one of the rural Nebraska area, where we have connected to the mid hall and connecting to the one of our lab systems and terminate the internet in the lab. So these are some of these. And this 5G 6G test bed, as Brad mentioned, it can be on-prem or it can be going to the AWS, and it's a completely integrated with the real, ORAN ecosystem, which is OR, UOC, UDU, as well as on the core, or maybe you can use some of the tools that are available in order to test some of the RAN and edge applications. And this is the slicing use case where there are multiple, when we take the rural connectivity especially, and residential telehealth, we have some small businesses and education and agriculture, right? And who might need a different quality of service for depends on the IoT sensors, cameras, or maybe video broadcasting, or just for the internet purpose, right? Depends on that, we can actually carve these multiple slices, and 5G 6G test bed will have this feature, and in order to support the multiple use cases to do the slicing operation. Yeah. So these are some of the use cases that we tested, and if you have any questions, please send me an email, and I have my connection there. Yeah. Thank you.
Any question? Anybody? Oh yeah, Henning.
Thank you, very interesting. Glad you were able to put it together. What wasn't quite clear to me is most of the examples that you described tended to be at the edge and observation, as you could trace traffic, Wireshark examples, and the DSCP, as well as do traffic experiments. How much flexibility do users have to inspect the software, like putting waypoints into the software, replace modules in the software to do more research on 6G modifications to 5G, that type of thing? Be more active.
Yeah, definitely it can be done, right? So one is NFVI, which is the infrastructure, and it will go to the virtualization layer, and on top of that, this cloud native container functions are coming and deploying. So definitely there will be a lot of evolution will happen on the infrastructure side, as we can load the same cloud native containers on top of it, and we can continuously optimize it. So we can build some of these observability closed loop functions that can be, restart, reboot, heal, migrate, some of these functions within that.
So let me answer. We got about what dozen demos, right? But Brad showed only one. The thing with closed loop automation, like you have attacks. Some of you might have seen the type of attacks that would have happened in United Nations or the SMS botnet type. We have experimented those things, emulated the attacks, and using intrusion detection system, detecting that and doing closed loop enforcement, changing the rules on the firewalls on the fly using SDN controllers. I mean, those kind of things we have done. We just didn't have time to do that. But I wanted to understand, are you talking about those? Are we also thinking of, we have started putting AI modules, like Internet of Agent type.
So let's say if you wanted to implement a new scheduling algorithm or a new authentication mechanism, or you wanted to change the plane structure, just to take the different layers if you want, in there, to the, like, evaluate some potential fixed fee idea that you might have, or just a different way of doing it. But if you can modify the software for your account, and not to, 95% loans, that's what they, and just modify your 5%.
Yes, and some are already doing that. And the cloud infrastructure we have, we don't send everyone to the same place. When we get a new customer, and at the organizational level, so a university or a company, we duplicate the original standard environment, set that aside and assign it to that organization. And so then it's theirs to, they have an admin, they can assign their own users, and they can customize it however they want. And that includes adding algorithms that can interact with the components that are already in there. And so I think it's the University of Calgary, they're writing algorithms that, define certain network slicing scenarios, inter-slice and intra-slice algorithms, and they're doing a long-term experiment on those in their version.
Henny, I just want to acknowledge, when I was doing my PhD in your lab, some of the test bed we built, that kind of instilled some interest and passion in me when we started working, but I wanted to acknowledge that. A question in the back.
This is great, that you're doing this on cloud platform. You said you're working with some vendors, are these big vendors, or is it like, I mean, I don't know if it's confidential, you can leave that.
So it's just, we have a certain amount of hardware that we've installed in IEEE, but